Hi, this is Dr. Mahmoud Al-Odeh. In this course, we will be talking about Lean Six Sigma. And hopefully this course will prepare you for the Lean Six Sigma certification by the Associate of Technology, Management, and Applied Engineering. ATME, it's one of the national organization in the United States, and they have several certifications uh, that will equip professionals like you in the field. Why we get certified? Because we need to be distinguished from other people in the field to keep up to date and to get a better opportunity, job opportunity, promotion, or any of these things. So these just a few reasons why we should get certified. So let's go ahead and start. What is a Lean Six Sigma methodology? The Lean Six Sigma methodology, it's a process improvement method that will help organizations to improve efficiency, improve utilization, and it's combined two techniques. One called is Lean, and the other one is Six Sigma. So these are two different techniques. They combine them together to bring up the Lean Six Sigma technique. So the Lean Six Sigma, it's a comprehensive tool. As I mentioned, it will help organization to improve efficiency for any process. Using this technique will help you and organization to improve revenue, reduce costs, and improve collaboration, whether between partners or inside the company as a team. So it is a team-based methodology that will help organization to improve efficiency, cut on cost, improve revenue, and so there are a lot of advantages that we could gain from this methodology. Let's start with the Six Sigma first, and then we'll move on to the Lean. What is the Six Sigma? It's a problem-solving methodology that we use numbers, qualitative technique to reduce the amount of defects of products or services. We need to reduce this through this techniques, through this methodology. Again, the whole idea of implementing the Lean Six Sigma and the Six Sigma itself is to improve customer satisfaction, reduce variation. This technique in particular, the Six Sigma in particular, will help organization to reduce variation because we are targeting to reduce the number of defects. We need to reach to 3.4 million defects, 3.4 defect per million. And also eventually will help improve efficiency and increase revenue as well. Six Sigma is a driven technique. It's a data-driven technique, which means that we use the data to make our decisions. So it's not about philosophy. It is a data-driven, which means it's based on facts. It's based on numbers that you could see the improvements based on these numbers. And one of the techniques that we use, or some of the part of the Six Sigma itself, we use the statistical techniques, and we need to reduce the defects again to 3.4 defects per million opportunities, or what we call it DPMO. DPMO. Six Sigma methodology consists of 5 phases: define, measure, analyze, improve, and control. And this is what we call the DMAIC methodology. The define is basically define the problem. What is the problem? What the requirement for this product to be able to satisfy the customer? We need to keep an eye on the customer. We need to ensure that the customers are fulfilled with their needs. We need, the second phase is measure. Measure what do you have current data. So you can't do any improvements without looking into your current data. So you have to look into your current situation and say, okay, well, yeah, I see there's a problem right there. Based on the current data, you could do the improvement. So the second phase in the measure, what you need to do, you need to collect the current data. And then once you collect the current data, what you do, you analyze it. You say, okay, well, let me take a look into this data and see where's the problem, how I could identify the root cause of the problem. And then once you identify the problem, then you could bring the solutions, and this is in the second phase, improve. Improve is implement, fix, that would solve the problem. So these are where we implement solutions to get rid of these problems, or at least to reduce the impact of these problems. And the last phase in the Six Sigma methodology is to control and sustain the results. So once you identify the problem and implemented these solutions, you need to maintain it and do look for more continuous improvement activities. These are the things that we need to take a look at. Before we move on, let's take a look into the history of quality and why we should study this. So I like this quote by William Foster. Quality is never an accident. It is always the result of high intention, sincere effort, intelligent direction, and skillful execution. It represents the wise choice of many alternatives. And we should study the history of quality because there are a lot of theoretical studies that we need to know about it. We need to see the basis, the foundation of quality, where the lean came from, where the Six Sigma came from, who are the pioneers in the field. For this class, I will be talking about Deming, JURAN, CROSBY, ISHIKAWA, and TAGUCHI. Start with Deming. Dr. Edward Deming was born in Iowa, and he earned a bachelor's degree in electrical engineering. And then he finished his master's and degree. The main contribution for Dr. Deming is the plan, do, check, act cycle. So he proposed this model and say, okay, if we follow this model, we will be able to do a quality of products or quality of service. So just follow the plan, do, check, and act. We will talk about it in more details later on. Also, Deming wrote a book, Out of the Crisis, which basically have a 14 guidelines, management guidelines, could be used by the US companies. If you read the history, there was like the Japanese were getting out of the Second World War, and then they have to use whatever the material they have to improve their quality. And then they've learned a lot of quality techniques. And one of the people who implemented these quality techniques is Deming. But Deming implemented these quality techniques back in Japan. Even he's a US citizen, but he went to Japan, applied these techniques, and he wrote this book, Out of the Crisis. And he was hoping that the US companies could use these 14 management guidelines to improve their products and start competing with the Japanese manufacturing. So there's a lot of story about the history back there, but let's focus on what the main contribution for Deming. Deming, and because of his contribution to quality, the Japanese Union of Scientists and Engineers has incorporated the Deming Prize. So they initiated saying, okay, well, this Deming did a lot of job, did a great job in implementing qualities, implementing theories, came up with different models and different philosophy, 14 guidelines. We will create a prize and we will call it Deming Prize. So this is the main contribution. And then this continue until this time that there are a lot of people getting the Deming Prize for quality. So it is a great achievement just to say, okay, well, thank you, Deming, for what you did for Japan. Here's a prize for you that we will create it after your name. Moving on to the next pioneer, JURAN. JURAN is also immigrated to the US. He's a US based. However, he's originally from Roman. And he's electrical engineer as well as Deming. And then the main contribution for JURAN that we need to be aware, it's a Pareto concept. Pareto concept, it's a very important concept that we start using it, which means 80% of the quality improvement can be achieved by fixing 20% of the problem. So they're saying, okay, focus on these 20% of the problems that will give you issues, and then by fixing these 20% of the problem, you can get 80% of the quality improvement, or what we call the 80-20 rules. So this is the Pareto chart. This came from JURAN, and we're still using it. And there is a chart called Pareto chart. Pareto chart is also based on this, the 80-20, and we could use the chart to see where's the 80 and where's the 20, and focus on the only 20% of the problems, so we could improve 80% in quality. JURAN also wrote a book called Quality Control Handbook, which provide information to companies for improving performance through better quality. So these are just books that we still use in the current field, because these are having a lot of ideas, a lot of creative strategies that we could use and implement here. And one of the books is JURAN's book, Quality Control Handbook, which is used here. Also, he came up with a new model for quality, which is called the Quality Triology Model. And Quality Triology Model is focused on quality planning, quality improvement, and quality control. These are the three things that we could take a look into in order to improve the quality. Quality planning, improvement, and control. And once you look into this circle, you will be able to improve quality. Now we're moving into the next person, CROSBY. CROSBY is born in West Virginia, US. He worked in the Navy. He graduated from the Ohio College, in the medicine college in Cleveland. However, he did not like medicine college, so he needs something more exciting than his work. So he joined the American Society for Quality, and then he contributed to the quality field. And some of the things that he contributed in this field called conformance to requirement. This is concept that he came up with, and there's in order to achieve the customer satisfaction, what we need to do, we need to ensure that we are giving them, having a service attached to the requirements. It's similar to the requirements, or what we call the conformance to requirement. Also, he came with a concept is zero defects in order to also improve the customer satisfaction. Measurement of quality is the cost of non-conformance. So they're saying, okay, if you want to look into the cost of quality, look into the non-conformance. And this is another concept that we'll be talking about it in this course, called the cost of quality. Ishikawa, another Japanese guy who did a lot of things, and one of the things that he came up with, quality circles. This is one of the things that he came up with. Quality circles, basically bringing a multi-department team to sit together and figure out what would be the best way to solve the problem. So bring a representative from each department to get them together in one room on one table and start brainstorming how they could solve the problem. So this is what it's called, the quality circles. So he came up with this quality circles. He's a recipient of Deming Prize that we talked about it earlier, but the main contribution for Ishikawa is the fishbone diagram, or what we call the cause and effect diagram. And the cause and effect diagram, it calls the fishbone because it looks like the fish bone, as you see here on the right side of the screen. The problem, the effect will be the head of the fish, and the causes will be on the body of the fish. And he divided this into the 6 M's. The 6 M's is the material, method, manpower, machine, mother nature, and measurement. And then you start brainstorming about what is the effect and what the cause. What is the problem? Why this problem is happening? And you start brainstorming about the causes. And if there's a secondary cause, you list it as well. Ishikawa also expanded the Plan, Do, Check, Act, the Deming cycle. They add sub steps inside these in this cycle. They added the in the plan, determine the goals and targets. So give a more explanation. Also in the plan phase, you will see the determine methods of reaching goals. How are you going to reach your goals? And then in the do, he came up with engage in education and training. So this is another important aspect in quality. In order to achieve high quality, you need to engage your employees in that. And then also he gave a sub step in the do, implement the work, and then check and act. It's still the same as DEMING. So the main contribution for Ishikawa, the fishbone diagram, and expanding the plan, do, check, act cycle, or what we call the DEMING cycle. He also talked about using the quality control charts, run chart, the histogram, the scatter diagram, Pareto chart, and flow chart, and this all will be explained in this course as well later on. But there are a lot of techniques that we could use to improve quality, and these are the 7 quality tools, what we call the 7 quality tools, and could be the control chart, the histogram, the scatter diagram, the Pareto chart, the flow chart, etc. And we did talk about the contribution to quality involve employees. So you need to involve employees in this. Last person in the quality history, it's Taguchi or Taguchi. Taguchi is a Japanese scholar. He also contributed to the quality. And the main contribution for him is the concept of quality loss function. Quality loss function in order to improve the quality. Quality loss function is used to quantify decrease in the perceived value of goods by the customer once the quality decreases. So he came up with a chart where he showed the relationship between customer satisfaction and the quality of product. And he said the decrease in inequality will also result in decrease in customer satisfaction. And also he came up with a design of experiment, which also will be discussed, trying different ways to see which one would work. And this will help quality improvement, because once you try different techniques and the first one did not work, the second one might work, the third one might work. So they give you a different way to implement the quality improvement and see how things are going to go after the implementation. The last thing that I want to talk about it here by Taguchi is the noise. Noise should be minimized whenever. So he talked about the noise as the external environment that might impact the process. So anything would impact the process would be called as a noise. And this is what we call the external disturbance as well. Impact the products. Of course, it will be impact. This is what we call the end control. Once you study the control chart, you will look into the natural cause of the problem and the unnatural. This is the noise is the unnatural. This is something added to the process, not from the process. So there's some noise in the process that you cannot eliminate. So you should keep that. However, once you study the process, especially using the quality control charts, you will see that there are a lot of external noise that you need to eliminate, and this is what we will be studying in the quality control charts as well. I'm gonna stop right here, and we'll go ahead and record another video. So this is the first part, and the second video will be talking about the evolution of Six Sigma, where the Six Sigma came from, and why we need to study the Six Sigma. See you in another video.